In this video, we'll take a brief but close look at the F256K system from conception in the original prototype through the production shipping version, which I received just a day or so ago. To start with, you're looking at the early prototype, at least the first prototype that Stephanie shared with the public. Going back to December of 2022, the juniors, the F256 Juniors, were just shipping. And I think they were shipping as dev boards, or it's possible that the dev board, no, I take it back. Dev board shipped somewhere around the August timeframe, and production version boards was shipping sometime around the end of the year. But it wasn't long before Stephanie became restless, as she does, and decided she would spin the board, attach a keyboard to it, put it in a custom case, decide which of the ports she would place on the outskirts, what the features would be, how, if at all, it might change. And what you see in front of you is revision A0A. I'll highlight for you on the bottom of the screen, about halfway across the board, on the bottom in red there, the serial number, and you can see it kind of lit up there in a red border. The newer versions, while I will not highlight them, are B0A on the left in the next part of this video, and B0B, which is the shipping version. The differences will be obvious, and I'll try and flash a miniature version of this graphic on the screen at key points in the main part of this video. But to start with, in the upper left, you'll notice two SID chips, or at least two, third-party back SIDs plugged into SID sockets, which are very much like the Junior has. Of course, there's a video which compares the Junior to this K, and I welcome you to go ahead and watch that. I'll put the link in the description below. But below this two SID chips, you'll see some other circuitry and jumpers for things like binding it to a certain stereo field or not, 12 volt versus 9 volt. And then there's an unpopulated 3-pin MTA slot where you would put a 3-pin header for audio in, should you decide to use real SIDs and not remanufactured SIDs. Real SIDs, of course, have an analog input, and there's a way to apply the low-pass, high-pass, band-pass notch filter, I think I named all the filters, to the incoming audio. Of course, the SIDs, or the third-party SIDs that are based on ARMs or 18 mega chips, etc., do not have analog circuitry. They're all digital, so not necessarily applicable. Regardless, this whole section here was part of our first prototype, and you can see it in front of you, and it was removed. And it was removed for a number of reasons, which I probably speak about in other videos. I won't cover it again here, but I just wanted to point out for you this part of the board changed dramatically. Next up, immediately to the right and highlighted in the red rectangle, is an area about the size of a 9-volt battery, and that's the ESP, or the feather board, which is a Wi-Fi board which adds or at least facilitates TCP/IP capabilities for the system. There's a long video, a very detailed video, a very well done video, put together by Peter, and I'll put a link to that as well. And it instructs you how to attach, how to order the feather, how to attach it to your system, how to configure it in your system. Here they show it's installed. Of course, it's an optional component. When you get your F256K, it'll come with a couple rows, and you'll see it in the next part of the video. A couple rows of holes to put header pins. But I at least wanted to show you where that exists on the board. Just below it are two jumpers that specify whether or not the system will be using this feather board if it's installed, or using the UART, or the serial port, for SLIP. And SLIP is a serial line over IP. So that's another way you can use TCP/IP, whether it be UDP or TCP, but it'll travel across kind of a slower speed terrestrial wire-based, copper-based DB9 connector that's on the back of every Foenix. So moving along from here, I wanted to point out two ICs, and they're identical, and these are WDC 65C22 versatile interface adapters. And those I refer to later. I didn't show a picture of it, didn't record a picture of it in kind of the live recording of this. But these are, provide connectivity to keyboard, joysticks, etc. And the reason there's two in here and just one in the Junior is that the keyboard on the F256K is, I'll say more capable, but it has more keys, really, in short. It has more keys, so a second one's necessary. The bottom one is just above kind of a wide keyboard connector. That's where the ribbon cable for the keyboard plugs in. And I think one last thing, and that's the reset button, which I refer to and show kind of the absence of in the next video, is there on the right. So it happens to be on this prototype board, and you won't see it in the live view of my other two systems. And then finally, of course, there's the FPGA in the middle. I just want to point this out because a lot of people, a little bit of mystery around it. Well, this is kind of the chip that is the equivalent of, I don't know, I'll say a VIC-2 chip, but on steroids. In addition to all the glue logic, a whole pile of utility and functionality that pertain to video modes, chip selects in normal systems are all embedded on some code that is I guess modified, enhanced over the course of time. And there are videos on how to upgrade this, at least from a software perspective. But it's this kind of square-shaped chip in the middle. This is a Cyclone, and Intel purchased a company named Altera, who kind of started the Cyclone line. And this is, it has a serial number on top. You can see at least a model number. That's important when you go ahead to, and it's time to flash new code into your FPGA. But I at least wanted to show what it looks like. It's this kind of mysterious square here, but it really is the heart of the system. Of course, the CPU is the real heart of the system. That's that 40-pin DIP you can see to the right. But everything else, the amount of real estate that the FPGA saves is just extraordinary. Also, the amount of utility packed into an FPGA like this, with a couple tens of thousands of cells or gates, is extraordinary. Also, it can be extended and it's extensible. So there are updates and upgrades to it. There are bug fixes that otherwise you'd have bodge wires all over the board. So I've said a lot of things about this board, but at least wanted to give you kind of the precursor to what it looks like in general. In the next part of this video, which I'll fade to in a second, we'll talk very specifically about the B0A version and the addition of a second FPGA to compensate for the absence of the SID sockets and the reason why. And we'll talk a bit about some of the other changes on the board. But much of it is very much like what you see here. It's really the same system in essence, but improved. So I'll step aside for a moment, and we'll be right back with kind of live view of me narrating a video that talks about the version B systems and where they went from here. What you see here is a pair of F256K machines. On the left is the prototype, which I received for VCF East back in, I guess, early April. And on the right is the production version, which I just received today, shipped to me. This is my own unit, which I purchased. I'm here to talk just briefly about the differences between the kind of the original design, although this is not the original design, and what's shipping today. And it's a little bit hard to tell by looking directly at it. There's more obvious changes on the outside, but they look very similar. Same keyboard, although I've got brown switches in mine. Prototype has blue. Of course, you can get any number of switches installed in yours upon ordering. I've got a battery in mine. There's no battery in this one, but otherwise it looks largely the same. There are a few subtle differences, however. And that's that the one on the right, which is my production unit, has the reset button in the back right, as opposed to the original placement, which was to be on the next to the joysticks, which some of the Commodore systems had the reset switch or the reset button next to the power switch, which was next to the joysticks. And of course I'm talking about a 128 and probably the +4 or the TED line of machines. You'll notice in the two of you that tried to place them next to each other, the SD card is slightly different in terms of the placement, and that's only because Stephanie felt that the cavity that she created on this unit, which was a prototype, didn't leave enough space for people that had larger hands and had to reach in there to push and pull the SD card out. So she moved it back more, and it's here now. And she moved the reset button around the back, which in this prototype it's actually in the back, but originally was planned for here. So that's just one very subtle difference. Otherwise, there's a difference in some of these connectors here, which are not on the production version, and instead you have a header here, which is not used. This is actually to program the Tryon FPGA. She does use it. She uses it once, which is to kind of push the code into the Tryon. This is version B0B, I believe, and this is B0A. If you go on the website and you look at the detail or details of the F256K system, you'll notice that A0A is pictured. And in fact, you'll see two SID chips here on the left side. You'll see no Trion. It's a bit of a different system. At some point, Stephanie decided, and again, it was prior to this prototype that was shown at VCF East. At some point, Stephanie decided, you know what, rather than put the two SID sockets on here and, you know, put the onus on the owner to purchase two SID chips, she decided to get her hands on an FPGA that was reasonably priced, could be integrated in with Gideon SIDs on board, so that every single shipping F256K came equipped with two SID chips. That way, all the software would work with it. So somebody could code something once and know that it would run on every K that's out there. In addition, she put an actual OPL3 on here, and that was on the prototype also. So that's the difference between the, I'm pointing to the left here, but that's the difference between the A0A and the B boards. And again, this is the B0A and this is the B0B. This is what ships today. Other than that, there's a little bit of expansion on here. There's a really good video by Peter about installing the the feather board on here, which is a Wi-Fi adapter. You'll need to solder a header on. You'll need to procure the ESP module, which is inexpensive. Install it and do some software configuration, etc. It's a little bit in depth. It was very in depth, in fact, his video. It takes a little doing, but it's certainly worth it. Otherwise, you'll note that the two jumpers here are strapped to the SLIP interface, which is IP over serial, which would leverage the DB9 serial connector, which is here. So that's the way it comes by default. The only other, I guess, part of this is that's unpopulated. It's fully populated, and I covered a bit of the detail, as have others, is this back aux in. So there's a 3-pin MTA kind of connector, or place for a connector, which has a left and right stereo input for the codec. So you can mix external audio with this codec chip, which is right here. I'll put the name of this chip in the description. I think Wolfson makes it. I've referred to it before, and it's a full feature, I think 5-channel codec, but you can mix the audio input with that. Of course, it's nothing to do with any SID chip or virtual or FPGA-based SID instance. This is simply to mix in analog audio into this chip with the onboard audio. And you'll need to solder it on there if you by yourself if it's important to you, and probably find a way to route the wire out. So that's it for the interior of the system. I'll mention that on this prototype on the back side, which I'll show in a moment, there was originally a door, an access panel, where Stephanie had planned some expansion boards. I'm not sure what they were for. Could have been for audio, I'm not sure. But she kind of abandoned that idea to make it more simple, more standard, and here we are today. Otherwise, on the front, there's a bit of difference in terms of the way that the structure of the case is manufactured. This is a lot more robust, I'll say, meaning that there's horizontal and vertical fins on the bottom, which maybe I'll show in a moment. Otherwise, it's near identical with the exception of this decal. So here it's just a drop-in kind of a paper decal with rounded corners. Here it's a large bubble, type of decal. I think these are manufactured overseas in Europe anyway, overseas from me. And much like the original, it has kind of the resin, liquid resin kind of drop-in. In addition to the resin case, these are kind of hand filled by Stephanie herself. You can see there's a little bit of a difference here between the color. And if you follow her, she's doing all kinds of changes with colors in the different systems that she sells today, especially on the 68K machines. So that's a quick overview. Oh, one last thing. This case the new case has, it said F256K here, but these were not labeled. These being the lock key, the media access, and the power LED. So here you can see that they're labeled. It's kind of hard to see, but you could see, I guess, rotated 90 degrees, the word lock, the word media, and the word power. And these are, I think, user programmable. You can program this for whatever color you like, I believe, by accessing some memory locations directly. I also wanted to, while I'm here, I'll mention that when you buy your K, you get a couple extra keys. There's a junior key and a K key, because this is the K, right? She throws in this Junior key. I think she buys a standard set, you know, regardless of what system she's selling, and just throws these in kind of as add-ons. And then you get the WASD key puller. I think she buys all of the keycaps from WASD. So you get the keycap puller as well. I also bought a RAM cartridge, and you may have seen that I had in one of my prior videos, or a couple of them, a prototype RAM cartridge. That's this one, and this is the production RAM cartridge. Profile, it's slightly different. This is more of a squared edge. This is rounded. This is thicker, I think. It looks more white, so it's more opaque, I'll say, so it's thicker. And there's a decal on here versus kind of the inlaid name of what type of cartridge it is. And then something else that Stephanie does, and I bought one of these as well, she has now made available a flash cartridge. So in the same memory location, you can have installed this flash cartridge, which is black resin, has a really nice feel to it, and it's, you know, similar to, you get the QR code on the back. It says flash expansion versus RAM expansion. But again, it fits in here as well as I believe most of the Juniors, so it's interchangeable. I haven't tried this yet. I'm not sure how what goes into flashing code. It's probably done through the USB interface, but I'll get to it shortly. So I'm going to pause this here, and I'll be back in just one moment with these assembled. I'll show you the underside, and we'll wrap this one up. So here you are again, the top side of both systems. They're now reassembled. I covered the differences, at least in terms of the label, the inlay, which is just color, the labeling of the LEDs. I'll show you quickly the side, and specifically the reset button. Originally was going to plan to be here, but is moved around to the back, and this was pushed back just a little teeny bit, give more room for people that have larger hands to reach in and grab those little SD cards. Let's see, this one, you could see a better look at it here. So, and then I think the joys are labeled here, the joysticks. They're not labeled on the prototype. The other thing to mention is, of course, on the back, or the bottom, there's a bit of a difference. And the B0A, yeah, here, had that access panel I mentioned previously. On the pictures on the website, you'll find that there's actually a header here, which I think was in the A0A version of it, and I hope I have the numbering correct. If not, I'll correct it on the screen. But you know, she as I said, she abandoned this in favor of you know, simplicity, something that didn't really have to go crazy with expansion units and support and a lot of issues that would come with it. The FPGA really helped her to get to the point where things were, you know, she can consider a platform that's very stable, which I think was the right move. And you'll see all the differences here. The similarities, of course, the dip switch bank, the FPGA JTAG interface. This is how you program or push new FPGA code into the Cyclone, which is on board, not to be confused with the Trion FPGA, which is on board. This is the production decal, which shows kind of dip switch settings. I think maybe in the old one she intended on putting it here, which I'm glad she didn't, because it would have covered these screws. And then structurally, this is a thicker base. It's a nicer finish. If you could see it hopefully in the light here. And these fins it's a thicker floor, and also it has kind of cross members for extra support. Here I wouldn't call it flimsy, but there's some flex. And I think that might about do it. I also wanted to mention, and I'll put it up on the screen, that I referred to the WDC 6522 versatile interface adapters that are used for the keyboard. I think I mentioned it in one of the kernel videos. So if you're on the screen up here, I'll kind of insert, you can see it, the two is that better? Not sure. We'll see how it turns out. But the QFP, I think, the quad packaged versions of the WDC 65C22, I believe. And you know, the original Commodores, of course, had 40-pin packages, and in some machines they were socketed. On the Junior, and I'll grab my Junior. This is, of course, a development board Junior, but you can see on this Junior, it's also socketed. It's over here. It's a 6522 socketed IC, and on this system, it's for the joystick ports. It's for the keyboard, the Commodore keyboard connector. Of course, on the K, you need quite a bit more because you've got additional keys which don't appear on the original Commodore connector. Hence the need for the pair of them. And I think that'll about do it for this video. I just wanted to at least touch upon those. I'll mention again, and I think I mentioned prior, that one of the things that Stephanie does routinely is iterate, right? She starts with the design, she makes changes to it, she makes improvements to it, she adds more functionality to it, improves the assembly. This has come quite a ways from the original prototype. Of course, this one is quite a bit evolved, but this was, I think, shipped to me in April. It was probably assembled just prior to her completing it, and I just received this today, and I was happy to let my original order go and give it to somebody else, because I've got plenty of Foenix products and plenty of work I'm doing with software. You know, if you're interested in picking one up, I believe that she has them available on her site, so hop on there and take a look. It's really a great product, very versatile, and you know, you'll get years of enjoyment out of it, I'm sure. Thanks.